PAWS, personalized arm and wrist movements with sensitivity mappings for controller-free locomotion in virtual reality. The authors are Sohan Chowdhury, William Delamare, Pourang Irani, and Khalad Hasan. In virtual reality, users use locomotion techniques to move through the virtual environment. Teleportation is a widely used locomotion technique for VR, with hands-only teleportation being a promising option for the controller-free locomotion. However, when controllers are removed, as shown in A and B, the differences in various physical attributes between users become a contributing factor. Taking into account these factors has not been previously explored for controller-free locomotion. Due to the differences in physical attributes, two users, such as shown in A and B, might get different experiences when using their hands to control the teleportation parabola. In this paper, we propose PAWS, which fully personalizes controller-free teleportation to each user and provides them with an improved locomotion experience. So our contributions are PAWS, a personalized hands-only teleportation technique for VR, and an exploration of varying degrees of personalization and different mapping function to stabilize that personalization. So when we talk about degrees of personalization, there's three primary attributes: how much you can move your arm horizontally, how much you can move your arm vertically, and what kind of wrist angles can you do with your wrist. It is not clear if all these attributes warranted a personalized counterpart or only a combination of them. So we did pilot studies to narrow down the possible combinations. From our pilot study, we found three promising candidates: the baseline, which is no personalization, personalized arm, which only personalizes one attribute, and full personalization, where all three attributes are personalized. So in study 1, we explored these three techniques with 3 distances and 5 different elevation changes, and our participant numbers were 12, with a mean height of 162.5 centimeters. In the study, participants teleported to different platforms placed throughout an environment. The results from our study showed that PAW with full personalization performed significantly faster than all other techniques, and users are also shown to be quite slow when navigating to high elevation points. When we look at user preferences, users significantly prefer personalized techniques more compared to other techniques. So from study 1, we had some observations. For example, some difficult to reach destinations required extreme arm extensions and wrist angles, and the trade-off for controlling a large pointer movement range using a small physical movement range for some participants can create some sensitivity issues, which is a trade-off. So to improve upon these observations, we explored sensitivity functions. Can they improve this? When exploring sensitivity functions, there can be many different options, such as sigmoid, which is more precise when the values are low and more stable when the values are high. There's inverse sigmoid, which does the opposite. There's a quadratic, where the values are more stable when in the middle, and in the lower and higher ranges, they are more precise. However, investigating all the combinations possible with a study is practically infeasible. Therefore, we decided on the combinations based on a pilot study and prior work related to mapping sensitivity functions to motor controls. Here, the terminologies, for example, SSQ means sigmoid, sigmoid, quadratic. Sigmoid is used for the first 2 attributes and quadratic for the last one, and so on. Prior work related to mapping motor movements with sensitivity functions provided similar recommendations to the combinations we tested. So in study 2, we explored 5 techniques: base PAW and the 4 different combinations, 2 distances, and 3 elevation changes. Results from our study showed that SSQ and IIQ were the combinations that performed significantly faster than all other combinations. In user preferences, no significant results were found. However, some participants commented that they liked IIQ more due to it helping them with their shaky hands. So, our studies show that full personalization with sensitivity functions provide a faster and improved teleportation experience to users. From our studies and results, we provide some design guidelines as well. For physical attributes and personalization, consider full personalization of all available attributes, map motor profiles to sensitivity functions, and combine similar sensitivity functions for connected movement as we found in our results. Our study had some limitations such as participant diversity, small sample size. We did not measure fatigue quantitatively. Our exploration was done with standing teleportation. We did not explore seated teleportation and so on. In conclusion, with fully personalized wrist and arm teleportation with sensitivity functions, users of various physical attributes can enjoy an improved, faster, and controller-free navigation of large virtual reality environments. Removing the need for controllers for locomotion opens up a vast design space not only for teleportation but overall controller-free hand-based VR interactions.